Next, we have example 2 in lesson 1-2, and we're going to take a look at the graph of f of x, or y equals 2x minus 6, and we're going to reflect it across the x-axis. A little vocab here. Remember that a reflection is a transformation that maps each point to a new point across a given line, which is the line of reflection. So for that, if we're going to go across the x-axis, let's go to our calculator, clear this out. The equation was 2x minus 6, 2x minus 6. Take a look at this on standard window. And if we're reflecting across the x-axis, meaning that the x-axis will be our mirror line. So every point is going to see sort of a twin point on the opposite side of that line. So our y-intercept of negative 6 is going to flip up to positive 6. 1, 2, 3, 4, 5, 6. This point, for example, at that would be 4, 2. If we're flipping it over the x-axis, it's going to go down to 4, negative 2. Okay, and that means that our line will connect these two red points. Sort of go like that. We reflected the black line to turn it into the red line. Notice the point 3, 0, which was its x-intercept, did not change. So let's see what did happen. 0, 6 became 0, negative 6 became 0, positive 6. 4, 2 became 4, negative 2. So if you think about this, all of the y values have changed to their opposite. Okay, the y values changed to their opposite. The point 3, 0 did not change because the opposite of 0 is still 0. So let's think about the equation that we would use to create this graph. To reflect over the x-axis, to change everything so that the y's are opposite, what we're going to do is we're going to stick a negative sign in front of the function, like this. The slope was 2x minus 6. The slope was 2. So to flip it downward or upside down, you want to put a negative sign in front of the whole function. Okay, again, negative sign in front of the entire function. So put the function in parentheses. And we're going to distribute that negative sign through. So what happens when we take the negative to the 2x? And what happens when we take the negative to the other negative? It's like a negative 1 is multiplying by negative 6 to turn that into plus 6. Ask yourself, is this the opposite of f of x, the equation that's going to produce this red line? Is this the graph of negative 2x plus 6? I think so. It's got a y-intercept of positive 6, a slope of down 2, right 1. Down 2, right 1. This looks good. We have our answer. Okay? So again, to reflect it over the x-axis, we put the negative sign out in front of everything. In B, to reflect it over the y-axis, let's work from the graphing calculator again. Clear all this out. But this time, our y-axis will be our line of reflection. So this time, we're going to take a point, for example, like 3, 0, and reflect it over here to negative 3, 0. So this time, we're turning the x's opposite. A point down here like negative 1, negative 8. We're going to flip that over that yellow highlighted line and make it 1, positive 1, negative 8. it was at -1, -8, and it's flipping to +1, comma, -8. The other point at 3, 0, the other point 3, 0, sorry about the technical difficulty. Something just froze, so I had to recreate this. But the point right here at +3, 0 flipped over to -3, 0. All right, so the two red dots will be a couple of key points that I'm going to trace to create our reflected line. Okay, notice there's a special point here in the middle that did not change, 0, -6. The y-intercept is not going to flip because if you think about it, we're making all of our x's opposite this time. 3 became -3. -1 became +1. And 0 will stay at 0. Sorry, it froze again. Having a little technical difficulty, but we're going to go ahead and recreate it back on the Smart page, and I'm going to show you how to make this happen. So we have the original function being f of x equaling 2x minus 6. To reflect it over the y-axis, instead of putting the negative out in front, like we did on the previous example A, we're going to put the negative inside the function with x. So instead of putting it out here and distributing it to the whole thing, we're going to leave the 2 in place, change x to its opposite, and leave the -6 on the end as our y-intercept. Okay? That purple will go away in a minute. Let me fix that. 2 times -x minus 6. Okay, so what we have here then for the reflected function, negative times 2 is -2x. Sorry, -x times 2 is just -2x, and we have -6 as our y-intercept. And that would be the equation that would produce that reflected line. The proof will come from y equals. To reflect this line over the y-axis, instead of 2x minus 6, it's going to be -2x minus 6. And graph. There's the red line that I had there before. So, reflecting over the x-axis, you put the negative out in front of the whole function. Reflecting over the y-axis, you only apply the negative sign to the x. Okay? That can be summarized right here in the use structure portion. Let's go ahead and do the try-its. Let's go with example 2, and we'll discuss the next time we see each other in class.